talked about the mean in the parametric test, because the parametric test we know that the data are following a normal distribution, but the non-parametric tests are distribution free tests. They do not follow any specific distribution. So if they do not follow any specific distribution, so we are not concerned with the parameters. That is, what is the mean, what are the variances. So here the parameters are not there. Okay. So that is why it is less powerful than the parametric test. Now, parametric test we can say are the cornerstone of statistical analysis. We are commonly assumed that the data is normally distributed. Now, there are certain key assumptions. Everywhere you cannot apply the parametric test. Certain assumptions should be met. Okay, where the parametric test can be applied. So, what is the first condition? The first condition is the normality. What is the normality condition? That the data which you have drawn from the population, it should be normally distributed. So, it is the first assumption which should be met. What is the second assumption? Variances across groups should be equal. Now, what do you mean by the term variances? Variances is a very statistical term. So, simply if I tell about variances, it is the spreadness or the scatteredness of the data. Okay, so it should not be it should be equal. If you are comparing two or more groups, so in every group there should be likely equal. And what is the third one? It is the measurement scale. Data should be measured on an interval or ratio scale. So I think you know what is the interval scale and a ratio scale. Now what is the importance? Why we go for the parametric test? It is when the assumptions of the parametric test are met, then the parametric test, as I told you, they are more powerful than the non-parametric test. Meaning that they have a greater chance of rejecting a false null hypothesis. Sometimes, because when we start with the test, we should write down the null hypothesis as well as the alternative hypothesis. So sometimes we write about the false null hypothesis. So they have a greater chance of rejecting a false null hypothesis. And we provide more accurate estimates of population parameters. So what are population parameters? Because from the population we draw the sample. That is the sample mean, the sample standard deviation. So from this sample we will be giving a closer result with the population mean, population variances amount. Now let us see what are the various types or the common types of parametric tests. These are t-test and the ANOVA. Where t-test is applied, it is applied to compare mean between groups. So one is the one sample, one is the independent sample, and the other is the paired t-test. So here we cannot compare more than 3. Only maximum it is 2. When it is the comparison of the mean is maximum 3, then we have to go for the analysis of variance. Okay. Now in analysis of variances, we will see later on that sometimes we reject our hypothesis. But for any one of the group it may be rejected. So with the application of the post hoc or the t-test test, we can find out, okay, for which one we have rejected or our assumption was not accurate, what we have done. Then it is applied in the various fields including psychology, medicine and social sciences, where the assumption of the parametric test are often applied. So understanding this parametric test is essential for researchers. Why? Because as this tool can provide significant insight when they apply correctly. So next we will be applying or going through the various types of and the last one is the population standard deviation is unknown. So you have roughly an idea of the population, that from that particular population I have chosen the sample. So you don't have any idea about the population standard deviation. It is sigma. Okay. Now we are interested because all of us are going through research. Okay. Now all of us will have certain questions with us. Like this is the values I have, the data which I have with me. Now which test I should apply? Now research scenario is given to us. Suppose a nutritionist want to assess whether the average daily calorie intake of a group of participants differ from the recommended daily intake of 2000 calories. Okay. A sample of 15 participants is selected and their daily intakes are recorded. Now this is the question I have, for the data I have with me. So from this what I have, calorie intake of how many patients? What is the sample size? The sample size here is 15. Okay, so the number of sample size I have. Now what is the, it is given, the mean calorie intake, daily intake it is given. So what is the value? It is 2000 calories. So we are writing the null hypothesis because we should follow certain steps when we are performing the one sample test. So first step is to state the null hypothesis. So we have stated the null hypothesis here. So what is our null hypothesis? That is the mean daily calorie intake of the participants is equal to 2000 calories against the alternative. It is not equal to 2000 calories. Now from this null and the alternative hypothesis, again you are getting one information. What is the particular information you are getting? It is a one-sided test or a two-sided test. Now I have written a symbol not equal to. So that means it is two tick, not one tick. If it was one tick, either it will be less than 2000 or it will be greater than 2000. But I have not used any such symbol. I have directly written not equal to. So that means it is a two-tick test. Okay. Now first, how you will perform the question? First we have to calculate the sample mean. What is the data we have? The calorie index. So we sum up all the calorie index divided by the number of participants. So how many participants were there? 15 participants. You sum up all the calories divided by 15, you will be getting the mean x bar. From there you calculate the sample standard deviation. Now it is written, everywhere by the side you can see the word sample is written. Because from the sample we are drawing conclusion about the population. That is why we are finding out the sample mean, the sample standard deviation, everything. Okay. Not about we are writing the population mean, the population standard deviation. From the sample we are drawing conclusion about the population. Now our key statisticals, I have written a mistake to which more. Okay. Now we write down our calculate our key statistic. So what this is the formula? T equal to x bar minus mu by s by capital S by 2. So what is the capital X bar? Capital X bar is the sample mean. What is the mu? Mu is the hypothesized value. We are getting. I have told you we have to compare with the mean. So in the research question, it was there. It is 2000. So it is the value of mean. Yes, capital X the value will be calculated from this formula, and n we have it is the value 15. Now what is the next step while performing the t-test? We have to find out the critical value. So using the t-distribution table, we have to find out the critical value, or also you can find out from the any statistical software will be giving you the p-value. Okay, so you can find out in two ways. Either you can take the help of the table, statistical tables, or you can with the help of any statistical software we can get the p-value. So from there you can make a decision about you will be accepting or rejecting your null hypothesis. So these are the certain tests. Why you have gone for the one sample t-test here? Because here the hypothesized mean is given. Okay, and only one sample was there. So no comparison within groups or between groups. Okay, that is why we are going from the one sample t-test. Also we assume that our assumptions of normality is fulfilled. That is why we have performed the one sample t-test. So any question? Because I am going through the question, no question later on. Now in between you can answer. So I am giving you that from each other. And where this is used, this is widely used to evaluate the effect of treatment or conditioning by comparing two distinct population or groups. So this is the situation where we will be applying the independent sample t-test. Now this test is also having assumptions because each and every test are having their own assumptions which should be met. So what are the assumptions? One is the normality. You have understood the data from which we are taking should be normally distributed. The next one is the independence, that is the observation in each group must be independent of each other. That is, you are consisting of one group. So every member of the group should be independent of each other. Okay, same way the other groups which we have, they should also be independent among themselves. And the homogeneity of variance. So the variances of the group should be approximately equal. But how can you know that the variances are approximately equal? So for this also we have another test, and this test is the Leibniz test. If you know, have any idea about SPSS, so in SPSS if you run through this all tests are there, you can go through. Okay. So for to see the variances are approximately equal or not, you can go through the Leibniz test. Again, where we should apply and why we should apply. So for this we have a research question. So what is the question? Suppose a psychologist is there who wants to study the effects of a non-cognitive behavioral therapy, okay, on anxiety levels. So one group is there who has been given the therapy and the other group is there who is not given the therapy. So the one group who is not given the therapy is known as the control group, and the group which is given the therapy is treatment group. Okay, so we have the scores about the anxiety level. So the sample data we have for the treatment group as well as the control group. So how can you know that this is a research where we can apply the independent sample t-test? Because there are two. Yes, one group is receiving the treatment. They are like every time they are given to each and every member, and the other group is there who has not been given the treatment. So they are two distinct groups, but in between the groups they are independent of each other. So from them also we can know that we can apply the independent sample t-test. Now you see the sample size. The sample size should be relatively small. So maybe your sample size is 1, 2, 3, 4, 5, 6. So you can go for the independent sample t-test. Another thing what you should go through is the normality condition. It is very important. The data, the sample should be drawn from the normal population. So if these conditions are met, then I can, what is my first step? I should write down my null hypothesis. So what is my null hypothesis? There is no difference in mean anxiety scores between the treatment and control groups. So one group I write it as mu1 who is receiving the treatment, and the other group I write it as mu2 who is not receiving the treatment. Okay, let me, you will be getting this slide, okay? I should continue on, otherwise we cannot finish. So first what we should do, we have written down the So what we do, we have written down the null hypothesis and the alternative hypothesis. Now our formula is t equal to x1 bar minus x2 bar minus of mu1 minus mu2. If you can follow me. In the net you can get. But while we are going to the practical application, we don't consider minus mu1 into minus mu1 minus mu2.